Welcome back. In this video, we are going to solve problem example 6.4 that is taken from chapter number 6 bending, and book name is Mechanics of Material by RC Hibbeler 9th edition. So statement is draw the shear and moment diagram for the beam shown in figure 6-7a. So you can see this is a simply supported beam having roller support at point A and pin support at point C. And at point A, we have a moment that is clockwise 80 kilonewton, and from B to C, there is a distributed load of 5 kilonewton per meter and a point load of 15 kilonewton at point B. So you have to determine the shear and moment diagram for the beam. So let's start with the solution. The first step is that if you remove this roller support at point A, so you will be having a reaction force which will be represented as RA, and if you remove this pin support at point C, so you will be having a vertical reaction force RC as well. There will be this will be RCY, and there will be a horizontal reaction force which will be RCX. So we will find this RA, RCY and RCX by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0 and taking the counterclockwise moment as positive. You can see this is a distributed load of 5 kilonewton. So this distributed load, when converted into a point load, so this load will become equal to 5 multiplied by the length over which it acts, which is 5, and that is 25 kilonewton. Now we will apply this equation. So first force that is producing moment is RCY and perpendicular distance is 10, and this is producing counterclockwise movement, so it will be positive. So I can write RCY multiply by 10, and that is positive. The second moment that produced moment about point A is this 25 kilonewton load, and perpendicular distance is this one. Clear? So this is 5, and this distributed load will act at the middle of this 5, which is 2.5. So 5 plus 2.5 is 7.5. So this distance is 7.5 meters. So I can write it 25 multiplied by 7.5, and since it is producing clockwise movement, so it will be negative. The third load that is producing movement about point A is 15 kilonewton load, and perpendicular distance is 5, and it is also producing clockwise, so it will be negative. So I can write it minus 15 multiplied by 5. And the last moment that is at point A is 80 kilonewton, that is clockwise, so it is also negative. So I can write minus 80 is equal to 0. So from here I will get 10 RCY is equal to 25 into 7.5 minus 15 multiplied by 5 minus 80. And when you will calculate this, so I will calculate it 25 multiplied by 7.5. 25 multiplied by 7.5 will give you 187.5 minus 15 into 5, which is 75, I think. Yes, this is minus 75, and minus 80 is equal to 10 RCY, and 187.5 plus 75 plus 80 will give you 342. Okay, so this will give us 342. Okay, 42.5. So that is equal to 342.5. Okay, when this will move towards right, so this will be positives. So I will make this correction. This will be positive. So then it will give you 342.5, 10 RCY. So from here, what you get is that RCY will be equal to 342.5 divided by 10, and that will give you 34.25 kilonewton. Okay, so we have this. Now we will find this RCX by using another equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force toward right is taken as positive. And you can see that we have taken it toward left hand side, so minus RCX, and there is no other horizontal force, so it means that RCX is equal to 0. Now we have left with RA, and we can find this RA by using the third equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see RA, which is upward, so RA minus this 15 kilonewton minus this 25 kilonewton plus this 34.25 is equal to 0. So from here, minus 15 minus 25, minus 15 minus 25 plus this 34.25 will give you minus 5.75. So RA minus 5.75 is equal to 0. So from here we will get this RA will be equal to 5.75 kilonewton. Now you have these reaction forces, so we will move towards shear force and bending moment diagram. Okay, so let me write it: shear and moment diagram. For that we will define shear and moment functions. Okay, since you can see there is a discontinuity of this uniformly distributed load, because it is available on this portion and not available at this portion. Also concentrated load at the center of the beam, so we have two regions of X must be considered. First we will section the beam for this X1, and this X1 will be greater or equal to 0 and less or equal to 5 meter. And then we will section the beam in this region for X2, and X2 will be greater than or equal to 5 meter and less than or equal to 10 meter. So let's section it for region X1, which is greater than or equal to 0 and less or equal to 5 meter or less than 5 meter, you can say. So what we will do is that we will section the beam over here. Let this will be your X1, clear, and we will draw the free body diagram over here as well. So this is your point A. We have RA, which is 5.75. This distance is X1. Here you have a moment which is 80 kilonewton into meter. So when you section it, so you will be having a shear force which will be acting downward, and you will be having a reaction moment M. So we will find this shear and moment as a function. So for that we will apply equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see this 5.75 is upward. So I can write it 5.75 minus this V is equal to 0. So V is equal to 5.75 kilonewton. This is your equation 1. This is your equation number 1. Now we'll find this moment by using another equation of equilibrium, that sum of all moment about this point O, this is O point, is equal to 0 and taking the counterclockwise moment as positive. So you can see the first moment is 80 kilonewton into meter, which is clockwise, so it will be taken as negative. So I can write it minus 80. The second moment is due to this 5.75 into perpendicular distance X1, and it is also clockwise, so it will be negative, minus 5.75 into X1. And the last movement, which is reaction movement, that is counterclockwise, that is their sum of all this movement must be equal to 0. So from here you will get this movement will be equal to 5.75 times X1 plus 80, and the unit will be kilonewton into meter. This is your equation number 2. Now equation number 1 and equation number 2 determine the shear force and bending moment equation for this region. For x is equal, x1 is equal to 0 and x1 is less than 5 meter in between this region. For that, for another region, what we will do is that for region x2, which is greater than or equal to 5 meter and less or equal to 10 meter. So what we will do is actually we are going to cut this beam in this any region. So let this is your x2. Now if I draw the free body diagram over here, so it will be like this. You can see this is RA, which is 5.75 kilonewton. Clear? You have a moment here which is 80 kilonewton into meter. Let till this distance is 5 meter. This is point A, this is your point B, and at B you have a point load which is 15 kilonewton into meter. And from B till this point we have a distributed load, which is actually 5 kilonewton per meter. And the total distance which we have taken from this till this was x2. So this is x2 and this is 5. So remaining this distance will be equal to x2 minus 5 meter. Okay. And when you cut it, you will be having a shear force which is V downward and you will be having a moment M. So again here we'll find this V and M for equation of V and M by using equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see that the first upward force is this one, which is 5.75. The second one is this 50 minus 15. And the third one is this distributed load multiplied by the length over which it acts. So I can write it 5.75 minus 15 minus 5 multiplied by x2 minus 5. And the last one is this shear force minus V is equal to 0. So from here, what we will get is V is equal to 5.75 minus 15 minus 5x2 minus plus 25. So V will be equal to 15.75 minus 5x2 and the unit will be kilonewton. Let this is your equation number 3. Now we will find the moment, this moment M, by using another equation, that sum of all moment. Let this is your point 1, about point 1 is equal to 0 and taking the counterclockwise moment as positive. Again, here we have to convert this distributed load into a point load. So this load will be equal to 5 multiplied by x2 minus 5, and that will act at a distance half of x2 divided by 5 from both points. So this is actually x2 minus 5 divided by 2. This is divided by 2 and this will be the same, x2 minus 5 divided by 2. Okay. Now applying this equation, so first force that is producing moment about point 1 is this 80 kilonewton. This is clockwise, so minus 80. The second force that is producing moment about point 1 is this 5.75 and perpendicular distance is x2. This is also clockwise, so it will be negative. So I can write minus 5.75 multiplied by x2. The third moment is due to this load, which is minus 15 into x2 minus 5. And this is producing counterclockwise movement. Why? Because you can see this is the force and this is perpendicular distance, so it is producing counterclockwise movement, so it will be positive. And this last one is this one, which second last, this force into perpendicular distance is this x2 minus 5 divided by 2, and this is also producing counterclockwise movement, so it will be positive. So I can write plus 5 into x2 minus 5 into x2 minus 5 divided by 2, and the last moment, which is m, and that is counterclockwise, so their sum must be equal to 0. So when you simplify this equation, you will get this moment will be equal to minus 2.5 x2 square plus 15.75 x2 plus 9.92.5, and unit will be kilonewton into meter, and this is your equation number 4. Now equation 3 and 4 are valid for the region x2 is greater than 5 millimeter and less than 10 millimeter. So these are our shear force and bending moment equation. So with the help of this equation 1 and 2, we will draw the shear force and bending moment for this region, and for region of this one, x2 is greater than or equal to 5 meter and less than 10 meter. We will draw the shear force and bending moment by using this equation. So let's start with that. Okay, for shear force and bending moment diagram, again you have to draw vertical line from the end of this beam. Clear? Let me draw it. Okay, and there is a horizontal line for the shear force, and this x that will show you in length of beam in meter. Here on y-axis you have shear force having unit kilonewton. Let each division is equal to 5. So this is 5 kilonewton, this will be 10. Similarly, minus 5, minus 10, minus 15, minus 20, minus 30, 25, minus 30, and so on. Okay, starting for this first equation. So for shear force for region, you can see this is a single value, constant value 5.75. So it means that shear force will remain the same for x is greater or equal to 0 and less than 5 meter. So you can see this is the length of 5 meter. This is the mid of the beam. This is 5 meter. So from this starting point till this mid, it will remain same, and it will be 5.75 kilonewton. Now at this point you can see you have 15 kilonewton load, so 15, that is minus, so 5.75 minus 15 will give you 9.25. So again shear force will change from this to this. This is minus 9.25, and if you put x is equal to 5 meter in this equation, clear? So you will again get minus 9.25. Now for x is equal to, you can also plot various point of x2, clear, which is 6, 7, 8, 9, and you will get multiple point over here. So after joining them you will get the shear force, but here we will put x is equal to 10. X is equal to 10 meter in equation 3. So we will get V is equal to minus 34.25. So minus 34.25 will be somewhere here, minus 34.25. And again you can see that this distributed load is a 0 degree line. So bending moment, shear force will be 1 degree higher and slope will be decreasing. So we can join them by using a straight line. So this will be your shear force diagram. And you can see that it is correct because at the end you have RCY, which is plus 34.25, and which will cause it to move toward 0. That will complete your shear force diagram. So this is your shear force diagram. Now we'll move toward bending moment diagram. So for bending moment diagram, again I will draw a horizontal line, and x shows the length of beam in meter. On y-axis you have moment, and that having unit kilonewton into meter. Okay, so what we will do is that put x is equal to 0 in equation number 2. So when you put x is equal to 0, so this term will become 0. Also moment will be 80 kilonewton into meter. So m is 80 kilonewton into meter. Also you can see this 80 kilonewton into meter is available over here, that is clockwise, but while drawing the bending moment diagram, this clockwise movement will cause the bending moment to go in positive direction, which is already shown over here. You can see you get positive value. Okay, so let each division is equal to let's see, this is 25. So 25, 50, 75 and 100. Clear? So first one is 80. So 80 will be somewhere here. For example, this is 80. So at x is equal to 0, we have 80. Now at x is equal to, you can see at x is equal to how much? X is equal to 5. x1, sorry, x is x2, this is x1. Okay, so when x2 is equal to 5 meters, so put in equation number 4, you will get moment is equal to 108.75, which will be this one at the mid. Let's say 108 is this point. So 108.75 kilonewton. Also you can see that this shear force is a horizontal line, so bending moment will be 1 degree higher and slope will be increased. So you can join these 2 points. Again, if you need multiple points, so you can just place the value of x1, various value of x1 till x is equal to 5. So you will get this. Again, for x2 is equal to 10, put in equation 4. So you will get moment is equal to 0. So this is the equation when you put x2 is equal to 10 in this equation. So you will get moment will be equal to 0, which will be this one. And you can see that this shear force is 1 degree line and slope is decreasing. So bending moment will be a curve like this with clockwise direction. So it will be like this. It will be a curve type. And this is your bending moment diagram. So this was all about this example 6.4. I hope you have enjoyed this video and you have learned it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.